from one end of functional to the other, doing the absolute best possible to keep that together. Hi, my name is Alexander Yaffe, and I'm here to talk about the integration of Doobie and Quill. This is a lot of fun. This is basically the key parts of this Rob and I wrote in about an hour, so it's amazing how much you can get done with peer-to-peer collaboration in a short amount of time. So this is really neat, and I'm really excited to be up here and talking for the first time. So this is something that we came up with together when we realized just how sort of correctly Doobie and Quill fit together, because the purpose of them is to effectively solve different parts of that equation. So, let me adjust this thing. So, my name is Alexander Yaffe. As I've said before, Rob is not here, unfortunately. I was really excited to give the talk with him, but he has bronchitis, unfortunately, so let's all wish him well. Both of us are very reachable. We all go by the same handle on those channels. The purpose of Quill and Doobie is to be able to get functional programming to talk with these culprits below and their respective personalities. Now, that was effectively where Quill and Doobie aim to ask two different questions. The question that Quill asked is, how do you compose queries well, database queries well? Doobie asked, how do you compose database effects well? And that's where sort of the divergence in the architecture began. Now, let's talk about Doobie for a second. Now, what you end up having is you start with some SQL, right? You go to some kind of query that's parameterized, has some kind of structure, and then what happens is that you have this ability to create effectful computation. I think it was at a scale by the bay a few years ago where the question was, how do you actually describe what I/O and connection I/O is without using the word monad? And so I think it was actually John DeGoes who said that this is an application. This is an application of connection state that manages connection state that exists within a particular context and that can be executed and returns a particular kind of type. So in this case, where you have a particular type of row, you could return a particular group of records that exist within some kind of collection. The alternative to this is to be able to have something that represents a stream of records. Now, this stream is an FS2 stream, and one of the very interesting decisions that they've made is to separate out the effect type. So connection I/O is effectively an application that manages connection state. A stream of that is a stream of an application that manages connection state. Now, ultimately, these are functional abstractions. We need to get to a point where the database is abstracted out. That's the whole purpose of this. And so what we end up doing is we end up having eventually this turn into an application of just records or of just a stream of records. And the way that you do that ultimately is that you have this thing called a transactor. This has some very interesting architectural consequences. The fact that, for instance, Doobie does not need to hold database connections inside of thread locals in order to be able to manage asynchronous computation because it free monads out the entirety of JDBC. And so effectively you can set up your entire computation within these constructs and then have it all executed later. So this is a very, very interesting and exciting way of managing computations on databases. Now, the thing is, when it comes to Doobie, is that you get full composability, and you also get a guarantee of no side effects starting from the green line down, right? So Quill is supposed to do it from the green line up, but we'll talk about that in a minute. Now, let's look at what this means practically. So here's a Doobie query, right? So we expect to produce a record with a particular kind of structure, right? If the query doesn't have that kind of structure, if you don't return an age column or also return some other column, the thing will fail. Now, you have to write a test in order to do this because, again, this is a string. You're composing with strings. Oh, and by the way, it's actually not that bad. You don't have like SQL injection risks because ultimately the parameters of this are string interpolated, so you don't actually have to worry about that part of it. It just ends up going into a prepared statement. Now, what you can do, because ultimately this is a structural kind of construct, is that you can actually create case classes that have the same kind of structure, and effectively they're both, in fancy terminology, they're both categorical products, and because of that you can just assume that these things are isomorphic, and so you can interchange one for the other. Now, the next part of it is that what you need to consider here is that, again, all of this comes from a string. And because of that, what you could end up doing is you could end up reorganizing, for instance, the columns that are coming out in any sort of arbitrary way. Now, you need to write tests for this, and here's the thing. The tests may or may not pass, depending on whether you use Doobie to generate your data in the first place. So for instance, if you're using Doobie queries to read your data as well as write your data, right, the last name column is always going to be swapped for the first name column, so you won't even catch that in a test. On the other hand, if your tests, deal with raw DDL statements and inserts, then you will. But the thing is that you might not even catch this. And this is the part that makes Doobie no longer functionally programmed, no longer functionally type-safed on this kind of level. So, meanwhile, actual complexity comes in, right? In reality, we have tables that need to be joined, many tables that need to be joined. And so, for instance, here's a typical way of how you would do the permissions and roles of what somebody can do when they come to your applications party, right? Typically, all security databases work in a very similar way where you've got many-to-many mappings between roles and permissions. Now, we decided to add the additional complexity of 3 kinds of entities here, just what the hell? But this is reality. Oh, and by the way, when it comes to databases, you can't actually have a many-to-many mapping. You need to have mapping tables. Wonderful. Right, so in addition to our table or query for humans, let's have a query for trolls, right? When it comes to trolls, we want to do some additional things like check where they come from because we want to restrict their membership within our business logic in a particular way. And oh, by the way, based on some business logic, we may or may not allow them to have a particular kind of permission. Like trolls are not allowed to loudmouth in particular situations, right? This is the reality of business logic. Business logic is ugly and dirty and has arbitrary rules about what to allow and what to not allow. Now, what ends up happening is that we copy these joins left and right. And so we have copies and copies and copies and copies and copies of queries. But we don't want that, so we want to abstract it out. All right, let's abstract it out. Right? How do we do this in Doobie? Well, we have these fragments. We have these fragments that we can factor out. Ooh, we're assuming that our table has a particular alias. Let's go back, right? Troll has U here. We're assuming that that alias is being used here. Oh, and in addition to that, we're assuming that all the aliases that we introduced in order to join all of our other tables are not being used anywhere as well. Okay, this is getting interesting. Well, okay, let's move back up a level. So here's where we were. Oh, that's right. We need the name of the permission and the role, and we assume they had certain aliases. Right? Our type safety is quickly going downhill, right? What do we do about it in practice? How do we solve this problem? Well, we wish that we could do this on the level of SQL, right? We wish we actually had some kind of polymorphic API in SQL that could solve this problem, right? What if we had some kind of magical UDF into which you could pass a table type and it would join and return our table type and the stuff that we want out of it? Right? That's what would be great. That's what we have here, right? If we could just pass a table with a particular structure, i.e. an ID column, right? That's all that we need to join our roles and permissions. We just need an ID column, right? But oh no, it doesn't actually exist. But we wish we had this because then we could just use it to compose joins further downstream. But again, we don't. right? This is very sad. This is what Quill does. Quill gives you an interface that allows you to compose things like this, constructs like this, that are able to take a type of table. In this case, we're using duck typing. And effectively, this is a record type that contains an ID, because that is the only thing that we need in order to join to our roles and permissions tables. And so once we have this, we can join it further downstream. Okay? So this ultimately needs to be macro expanded, and we macro expand it. So here's an example of plugging query of person. It could be an arbitrary complexity query of person, actually. You could add arbitrary filters and whatever you want in there, but that's the contract. Anything, a query of anything that has an ID can be passed inside of here. And again, because this is a for comprehension, this works exactly the same way as Scala collections. All of the record types are what we would expect. That's a query of T that yields T, that's a user role, that's a role, etc., etc., etc. Right? We continue to compose downward. Now, the interesting consequence of doing it like this is that we can actually mix and match the kind of joins that we have. Right? This is an explicit join syntax that is also monadic. Right? If you've used things like Quill, you have a choice of whether you want to be able to do explicit or monadic. We have both. Now, what's the consequence of this is that when you left join, your entire row is null. How does Scala do nulls? How do we deal with nulls? The idiomatic way of doing it is with option. And so that's what we're able to do in this kind of construct. We're able to use option to effectively model nullity. Now, this is the equivalent of something like that you would have with Slick, which is effectively just doing the whole thing with if statements. But again, you can only do inner joins. You cannot mix inner joins and outer joins in this kind of syntax. And additionally, there was a decision made effectively to have this as an implicit join, not as an explicit join, because you don't actually say what kind of join here you want to have. Okay, so this is what Slick is. It is a Swiss Army tank of writing SQL expressions. And we have selects, we have inserts, we have updates, we have all sorts of DSLs to be able to pure functionally write Scala constructs that eventually generate SQL. And you can use these things, again, to compose further downstream. Now, eventually we have to turn this into SQL. This has to be useful, so that's what we do. We turn it into SQL and execute it on a database. But because this is where Doobie starts, we just continue and pass these selects into Doobie connection IOs that eventually go into transactors and that execute on your database. So effectively what you end up having is, you end up having a layer of Quill that's managed for the query side of it. You have a layer of Doobie that's managed for the effect side of it, and oh, there's that green line, except for now it's pure functional above and below the green line. Okay, so let's see a simple example of how this would happen. Here's our query that existed before, right? Notice how what we have to do anyway is we have to turn it into connection IO. We have to turn it into an application that manages database connection state anyway. All right, so let's just do that. And by the way, again, we can compose these things, freely compose these things, because again, these are connection IOs. And again, all of these compositions do not need to have thread locals in order to store connections. Now, let's add Quill. Right there. There's your difference, right? This is not a very high commitment API. You do not need to marry this API in order to use it. You just insert it into little parts of your query. Oh, we want to be able to have better composition here and there. Just splice it in here and there. This is not something that you need to massively commit to. And it fits perfectly into a Doobie pure functional stack. Again, all of the types that you have with Doobie are unchanged. Now, this is where we need to answer an interesting complication or an interesting difficulty that people talk about, which is that when you are composing things like this, what ends up happening is that you have all of these query compositions, and because they offer you all of these nice abstractions, you end up having a gigantic query that a database can easily choke on, or at least that an optimizer can easily choke on. Now, you actually don't know. You don't know what's coming out of something as big as this, right? And this is what you can find potentially in production. Oh, and by the way, you don't have aliases for variable names. Quill gives you aliases for variable names. Forgot to mention that, right? But, oh, and by the way, I hand formatted this, right? This does not come to you formatted, right? And then, what the heck? How do I make heads and tails of this? And your DBAs are pissed off, right? And so, how do you deal with this? Well, the way that you deal with this, and this is sort of the brilliance of the decisions of Flavio, who I hope is here. Oh, there he is, who created Quill. This was the brilliance: do it all during compile time, or as much as humanly possible, do it during compile time, so that you can see the query coming out of the compiler, and so that you can see it before you actually execute it. Now, you can have the best kind of unit testing in the world, but to have every single permutation of this multiply joined, multiply permuted slice and diced query is very difficult. So the way that we do that, the way that we implement that, is we use the Scala macro engine. And the macro engine is able to take this quoted block, this quotation, and before it actually compiles the code, it's able to parse it. And so we have a Scala tree, and we're able to turn that Scala tree into a syntax tree, a secondary syntax tree, that eventually becomes an SQL query. And we do all of this during compile time. So here's what your SBT log looks like. Here's what your scast log looks like. It is right there. You can see the query right there. And so you don't have to worry about, oh my God, what is the giant construct that this eventually is going to produce on some kind of database that's going to blow up in my face somewhere. You don't have to worry. This is it. This is what you are going to be executing, right? And you actually, the idea is to try it out. The idea is you can copy and paste it into some kind of evaluator, and you actually know that it works. We don't have this, by the way, for Doobie yet. For other flavors of Quill, what we're able to do is actually execute the query during the compiler. So before your compilation is done, we can actually tell you, we went out and executed this query on a database and it worked or it didn't work. We don't have this for Doobie yet. It's another exciting direction to go. And then on top of that, there are, although they're more rare these days, you still have some shops where the DBA team is powerful and demands to know what is going to be executed. And this is understandable because they need to be able to write the indexes if they're expected to manage the performance, right? They need to be able to know what indexes they need to create. And so they need to know the SQL in advance of that. So that's why ORM is still forbidden in some places. But certainly, if you know it, then you can create the indexes that are needed, if that's what your culture is like. But anyhow, a couple of caveats to be aware of when it comes to creating queries during compile time. Something that you have to keep in mind is that any value inside of this quoted block that's introduced from some external area needs special treatment because this is a runtime variable. This isn't something that the compiler has a value for, right? So this is not going to work. So effectively what we have is we have this lift construct, and the error will tell you effectively this name that's coming from this function argument needs to be lifted. And so you do that, and that introduces query parameters into the queries that your compiler will generate. Insert here, and we use prepared statement ultimately to encode this value, this external value. So that's the first part. The other part is when you're really starting to compose and pass queries into other queries. I don't have that yet, I'll show you in a minute. What you eventually want to do is you want to bring the whole function that composes into your quotation because you want your quotations themselves to be able to fully compose within each other. So that's why what we have here is we're returning a lambda instead of just declaring a function. That means that during compile time, this value name of this person in this case is going to be known. Now you don't need to lift it anymore. There's no lift because the function itself lives within its entirety within the quotation. So another thing to be aware of, by the way, is that type annotations, right? If we actually annotate the type here, quoted query of person, anything that lives inside of a quoted block needs to be this quoted, right? Well, the challenge here is that what Quill does is it uses refined types to store the intermediate syntax trees of all of your queries. And that's the challenge there. If you actually give them types, then the type refinements disappear, and we can no longer give you your query during compile time. We can give it to you during runtime. I mean, we can certainly still do that, but you lose the ability to know what it is during compile time. This is something that we're hoping to make significantly better with Scala 3, but a talk for a different time. The other thing that you have to consider is that when you're dealing, again, if you have heavy slick stacks, you'll see something like this where you actually pick query substructures based on compile time values. So Joe's and Jack's respectively based on a condition. Now the challenge here again is because you are building up your query based on runtime values, we don't actually know during compile time what the value of this runtime condition Boolean is going to be. And so we don't know which path to follow, and we don't know ultimately how to construct your query. So this is another thing you have to keep track of. Again, we can give you the query during runtime, we just can't give it to you during compile time. Now, the pattern that you use, and there's definitely more to be said about how to integrate this into more complex constructs, but the idea is that you wait to resolve your runtime conditions until you're actually executing your code. And so what you can do is, because you can compose queries into queries into queries into queries, what you do is you pass some kind of construct, whether it be a pre-filtered query, et cetera, into this final stage that evaluates based on the runtime conditions. So this is something that you have to keep track of. This run method here is sort of our end of the world or end of the compile time world. We also have, by the way, we also have stream. And what stream does is basically the same thing. Now, both run and stream, if you take a look below, what they do is they will actually build a query. And when you use this kind of pattern, you will effectively be building every single variation of that query that you need to have. Now again, what you can do if you have dozens of filters that you need to potentially introduce, that's another conversation. But at least for this kind of logic, you can build all the different variations that you need. Now, let's put it all together. Let's combine Doobie, Quill, HTTP4S, and FS2, see how this kind of application actually looks like. And we're going to be introducing a little bit. So, for small applications, and here's what a small application with HTTP4S, FS2, Doobie, and Quill looks like. So here's our RESTful endpoint right there. We create our Quill query inside of there. And again, this is not like the best development pattern in the world. You should be having data access objects into which you abstract all of your database code away. This is not what you should actually be doing. But this is really the beginning and end of it. You know, introduce whatever abstractions you want to introduce on top of that. So, again, this is a relatively small query. If you were not using Quill, that's what that would look like with pure Doobie. So it's not really that much of a sort of big bang for your buck for small queries. Now, where it really starts getting good is with large queries. So here's that giant join that we had before that we composed into an endpoint. So there's our endpoint right there. Oh, and we need to introduce trolls too, right? So there's our code copying, or there's our refactoring out. That's what that looks like. Okay, how do we do this with Quill? All right, well, there's our join tables like we saw before. There's our function that we've written. Okay, we take a query. Perfect, and we just use it. All right, let's just put it in. All right, so now we have people, and we can have people join to their respective permissions. What's the record type? What's coming out of this thing? Right, so Quill starts with a query that has a particular structure. That's a person, and that's actually a whole row, right? Person, first name, last name, right? One of the things that SQL requires is everything to be fully flattened, your record types that need to be fully flattened. We have taken care of this. Doobie actually also takes care of this. So you have structure that exists, and the two strings after that are the role and the permission name respectively. So there's what's coming out. This is the Quill side. We turn the Quill side into the streaming side. So again, this is a streaming application of a connection I/O effect that yields a record type of person, string, string. Okay, we call the transact, and then we just go to a stream of I/O out of stream of connection I/O. So we have abstracted out the database at this level, effectively. Now, we're ultimately returning this data to a client, so we need to do some kind of marshalling. And again, this is probably not how you should do marshalling, but just bear with me for the sake of example. Okay, and then finally, we have an entity that we return, and that's what comes out. So, let's introduce trolls. Right, that seems to be pretty reasonable. There's our second endpoint. I was actually going to introduce the third endpoint, but not enough time. So anyhow, I think I'll finish off here. Both Doobie and Quill end up going roughly where they attempted to go, where Quill does query composition really well, Doobie does effect composition really well, and composes into further things. It has great integrations into cats further downstream. And that's it. That's my conclusion. Go and insert some Quill snippets into your Doobie code today. And I'll take questions.
Anyone have questions? We have time for a few. Okay.
All right.
Well, oh, great. Wait. It's a big theater.
Macros are going away in Scala 3. What's the approach there?
So in Scala 3, I am super excited about it. We're going to be using inline. I think I actually did mention it, if I'm not getting deja vu. We are going to use inline in order to effectively compose our trees. And this is really cool because remember how I said you can't have type annotations? With Dotty, we will be able to have type annotations. And that will, again, because that integrates into other things like shapeless, for instance, that, as far as I can see, it will actually vastly increase the power and the capability of Quill once we have that functionality. And the macro system really does provide everything that we need to have. It's going to be an interesting challenge to get there, but it will provide us with a lot of capability that we do not have now.
Hi. So you have shown us the table, how we can join and everything.
I'm sorry, say that again?
You have shown us how the table can be joined, etc.
Yes.
Can we directly call the UDF on the database or the stored proc?
You want to call a store proc?
Yep, or the UDF.
Okay, directly call store procs and UDFs. So the way that you would do that, what Quill has, it has a construct called a query schema. And you can define within the query schema the thing that you want to call. So you could do it that way. There's also a query meta that you can play around with as well. There are a couple of different strategies that we have. One of the things that I haven't covered at all, actually, is that we have a construct called infix, a Quill construct called infix, where what you can effectively do is splice in arbitrary SQL that you want. And we use that for all sorts of things. Sort of infix is like the giant leak of our Quill abstraction, but it's a really good abstraction leak, and we use it for everything. So whenever you need to introduce different kinds of sort of very nitty-gritty SQL constructs, infix is how you do it.
Any other questions? Okay, well, let's give a round of applause for our speaker. Thank you so much.